Okay, so more with inequalities. Remember, we are working with chapter 2 in your textbook, so if you need a reference guide, you can go to your chapter to look at it. So let's review the word problems again. So remember, if you have a greater than or equal to symbol, at least or no less than. If you have a less than or equal to, they might use words such as at most or no more than. If you have just a less than symbol, they might use words like fewer than or less than. And if you have symbols like a greater than symbol, they might use words like more than or greater than. So think about those different words that mean the certain inequality. So in problem number 1, a number x is fewer than 7. A number x is fewer than 7. So fewer than would mean we're talking about less than. So then our answer would be in x has to be less than 7, right? It has to be fewer than 7, so less than. Number 2, my lunch can be no more than $6. So my lunch can be no more than, right? So it's not just more than, it's saying not more than, right? No more than, not more than 6, right? It can't afford anything more than 6. So it's saying no more than. So I guess we'll use L for lunch, and you can use whatever letter you want. So it doesn't matter what letter you want. I'm going to use L for lunch. So my lunch can be no more than $6. So it has to be less than $6 or equal to $6. Twice a number n is, right, more than 12. So do you remember from the last unit what twice meant? Right? Remember, twice means to multiply by 2. So twice a number would be 2 times n is more than, so it has to be more than, so just greater than 12. Number 4, I must eat at least 20 calories per day. So at least, it's like the minimum, right? That's the minimum you can have. So you can have more than 20 calories. So at least means that's like the minimum. That's the lowest number. So the number of calories has to be at least is going to be greater than or equal to 20. Think of at least as the lowest it can go, right? The lowest it can go. And think of at most is the highest it can go, right? It's the lowest it can go. Okay, let's look at the next set of problems. Tell whether the number is a solution to the inequality. Remember, to a solution, it has to make the sentence true. So we're going to plug in place of n, we're going to put positive 2 where n is. So negative 3 times n plus 1 is greater than negative 8. And where n used to be, right, I'm going to put a positive 2 where n used to be. And then we're going to work out this side by doing order of operations. So remember, order of operations, you multiply first, and then we can add. So on the left-hand side, we got negative 5, and the right-hand side, we have negative 8. So is negative 5 greater than negative 8? That is a true statement. Negative 5 is greater than negative 8. Right? Because negative 5 is closer to 0. So remember, when you're on the negative side, right, you got negative 8, got negative 5. The number that's closest to 0 is going to be the bigger number. The further you go to the right, the bigger and bigger the numbers get. The further you go to the left, the smaller and smaller. So when you look at negative 5, it's closer to 0, so it is bigger than negative 8. So this time we're going to plug in place of x, we're going to replace any of the x's that we see with negative 4. Right? So we have to show correct notation. So remember, when you have an exponent and you're substituting, you have to put a parentheses there. Right? So I have to put negative 4 where the x used to be. And then negative 4 where the other x used to be. So first you have to substitute and make sure that where the x used to be, you're substituting negative 4 using the correct notation. And then remember, negative 4 squared means negative 4 times negative 4, right? So negative 4 times another negative 4. Remember, that's 16. And then 16 plus 3 is 19. So on the left-hand side, we get 19. And then on the right-hand side, we get negative 5. So is 19 less than or equal to negative 5? No, that is false. A positive number is never smaller, never less than. Positive number is never less than a negative number. So that is false. Okay, when you're solving inequalities and you're doing your undo steps, there is a reverse rule. If you are ever multiplying or dividing by a negative number, you must remember to reverse the inequality symbol. So if you multiply or divide by a negative number, you must reverse the inequality. So let's look at the first problem. So it says solve and graph. So we have to undo multiplication, right? So we're going to undo multiplication by division. So we're dividing by a negative number. And so that's going to give us x. And because we divided by a negative number, I'm going to put a little squiggly there. We have to reverse the inequality. And then 28 divided by negative 7 is negative 4. And then we're going to graph that. So we're just going to put one tick mark just to make it easier so we don't have to do all the little tick marks. You know, we could put 0 and negative 1, negative 2, negative 3, negative 4, but just to save time, we'll just put the one tick mark. And then where are all the numbers that are less than negative 4? So we're going to put an open circle, and we're going to shade all the numbers that are less than negative 4. And the reason why it's an open circle is because there's not an equal to symbol in there. So remember, because we divided both sides by a negative number, we had to reverse the inequality. Number 2, we need to undo adding 9, so we're going to subtract 9. And that gives us x is greater than or equal to negative 11. So remember, to reverse or not to reverse, that is the question. So should we reverse inequality? No, because when you're adding or subtracting, you never reverse. So when you add or subtract, you never, ever reverse, right? Because it says only when you multiply or divide by a negative do you reverse. So when you're adding and subtracting, you never, ever reverse. So we just have to do all the numbers that are greater than or equal to negative 11. So it has to be all the numbers greater than negative 11 are to the right. And because of the equal to symbol, that means this should also be shaded, right? Because negative 11 is also equal to a negative 11. Number 3. Number 3, we have to undo subtracting 3 by adding 3 to both sides. So remember, these are your one steps, right? So everybody should be good at their one step. So that's negative 7 is greater than x, right? Negative 7 is greater than x is how you read that. And we do not reverse because when you're adding or subtracting, you never reverse when you're adding or subtracting. And then remember, we want to read this backwards. So we want all the numbers. So we want to read this, maybe rewrite it. All the numbers that are less than negative 7, right? So we can rewrite that. So open circle and all the numbers to the left. So make sure when you're shading, you're obviously shading and we can see which side you're shading. Number 4, remember how you undo division. So we undo dividing negative 4 by multiplying by negative 4. So we want to make sure that you guys are using the right operation. Show that multiplication on the side. And therefore it's x. And because we multiplied by a negative, we have to reverse the symbol. So we'll put a little arrow to emphasize that we had to reverse it. So all numbers greater than or equal to 8 is going to be to the right of 8. And it should be a solid circle because of the equal to symbol. So make sure that your open circles and shaded circles are noticeable. So make your open and your shaded circles very noticeable. Number 5, remember I can multiply by the reciprocal. So the reciprocal of 1/2 is 2. So I'm going to multiply both sides by 2. And that gives me negative 8 is greater than x. Notice I did not reverse. And the reason why I did not reverse is because I multiplied by a positive, right? I multiplied by a positive 2. It has nothing to do with the fact that this is a negative. It's what are we undoing? And I multiplied by a positive not a negative. It has nothing to do with this is negative. So therefore we do not reverse. And then remember, you could read this two different ways. You can read this -8 is greater than x, or you can read it the other direction, x is less than -8. So you can read it both directions, both ways. So we probably should rewrite that as x is less than -8. So notice I rewrote that. So all numbers less than -8 would be to the left, right? Because numbers that are getting smaller are less than. Numbers that are getting bigger are greater than. To undo multiplying by a -1, so remember this means we're multiplying by a -1, we need to divide both sides by a -1, and that's going to give me x, and since I divided by a negative, I have to reverse the inequality. So remember, I divided or multiply by a negative, I've got to reverse. And then all numbers that are greater than or equal to -5, because of the equal to symbol, it should be solid. And all the numbers that are less than -5 are to the left. So make sure when you're shading that it's noticeably what you're shading. Number 7, we have to undo adding 10, so we have to subtract 10. So should we reverse or not to reverse? That's the question. Remember, when you're undoing addition and subtraction, you never, ever, ever reduce. When you're undoing adding and subtracting, you never reverse. And so all the numbers that are less than -15 would be an open circle, and all the numbers less than would be to the left. We're going to undo dividing by 5, so we're going to multiply by 5, right? So that's going to give us n is greater or equal to -5, and I did not reverse. Do you know why? Because it says only when you're multiplying divided by negative. I multiplied by a positive, so I do not reverse. So we multiplied by a positive, so you do not reverse. So all numbers that are greater than or equal to -5, because of the equal to symbol, you got to make sure that you have that shaded. And greater than, numbers that are greater than are to the right. To undo multiplying by -1/3, remember we can multiply by the reciprocal, so we can multiply by -3 to both sides. And should I reverse or not to reverse? That's the question. Well, since I multiplied by a negative, the rule says if you multiply or divide by a negative, you have to reverse. So all the numbers that are smaller than -6 would be to the left. So it's just your one steps. It's just that you only have to remember when do you reverse the inequality. So whenever you multiply or divide by a negative, you have to reverse the inequality. When you're adding or subtracting, no matter what, you never ever have to reverse. So only when you're multiplying and dividing by a negative. So we multiply by a negative, therefore we have to reverse rule, right? We have to use the rule that we have to reverse since we multiplied both sides by a negative. Okay, just remember when to double check and make sure that you're double checking if you should have reversed or not. Make sure you're shading in the correct direction. Make sure that you watch your integer signs, and make sure when it's an open circle versus a shaded circle. So remember, when you have an equal to symbol, that means it should be shaded. When you have an equal to symbol, that means it should be shaded. When you have an equal to symbol, that means it should be shaded because it's included as an answer.